Hi, I'm Tom Green, your host here on ETV, back with another NECA IBEW video on this award-winning website. Wind turbines are popping up all over the United States, and we've shown you stories on how the NECA IBEW team trains their craftsmen and women on wind turbine installations, and then a couple of job-specific videos where those skills are put to the test. And just as important as the installation is the equipment. Wind turbine blades spin and cut through the air at incredible speed, with incredible force. You ever wonder how they're tested to ensure that they'll stand up to that stress? Dominic Geritano has our story today from Charlestown, Massachusetts.
Today's wind turbines are modern marvels. They sweep across vast landscapes, just waiting to spin into action. And along with all the intangibles a wind turbine brings, what's becoming more and more critical to every manufacturer is making sure the blades are strong enough to withstand the most extreme conditions. A 20-year life is a standard by which all turbine blades are measured. Just as our world waits for nothing, waiting 20 years to see wear and tear on a prototype blade has been put into warp speed. Here at the Wind Technology Testing Center at the Massachusetts Clean Energy Center, the largest testing lab on the planet, blades are put through the 20-year life stress test in a matter of 2 months.
To put it in context, it's like if you have a Category 5 hurricane wind speed hitting the wind turbine. We want to make sure the blade doesn't break. It tucks away, it saves itself, and when the hurricane's gone, it will go back to work again.
Turbine blades can be damaged or can break in 2 ways, flap-wise and edge-wise. Flap-wise relates to the stress the blades are put under when it's being spun by the wind to produce power. Edge-wise testing relates to the stress blades are put under when gravity is at work. Here at the facility, an actuator mimics both flap and edge stress with more expediency and precision than Mother Nature. This blade is currently undergoing an edge test, as we saw earlier, and is the typical size for today's blades, around 50 meters. But here they can test blades as long as 100 meters. That's longer than 1 football field. From the actuators to the high-tech computer collection to the high bay lights, all the power for this facility was wired by NECA contractor Daigle Electric and IBEW Local 103 electricians.
Well, the equipment is electrically fed around here. Even though they have hydraulic pumps, the pumps are fed from the switchboards. As you can see, there's miles of conduit in this project. Everything's fed disconnect switches. All these pumps weren't here, but we had to provide the disconnect switches and the receptacles for them while the construction was going on. We didn't even know what the specs were on a lot of these pumps prior to us starting and finishing the project.
Local 103 folks were here towards the end when the building was almost done, and that's a difficult time because we started having visitors.
I'd say the height was challenging. We're 86 feet up in the air to put the digital lumen LED lights up on the roof facing down, and the wind coming off the water right there. And the sides weren't up when we were putting the lights up, so that was probably the toughest part, is going through the weather at that point in time.
That's where the job started. We started in the sailing because we wanted to get in before all the other trades. And, you know, spent a few nights there and installed all the conduit, lighting. They are very efficient.
The high bay lights are from a local company called Digital Lumens. They are all LED lights. They all have their own IP address. You can control every light individually, regardless of circuitry. There's 100 lights in the ceiling. As you can see, they give off an adequate light level and energy efficiency, which is important to the owner.
It's much smaller. You know, the other big CFLs, you can see the whole dome, the aluminum dome. But it's also helping because we've had 2 or 3 warehouses come and say, hey, how does this work? Maybe we can do it.
We couldn't go straight across underneath. By the time the electrical contract was awarded, the base slab was already poured. The first day we actually showed up to the job to do coordination drawings, they had the structural steel sitting here and they were getting ready to erect it. So the only conduit that's underground is the conduit feeding the transformer to the switchgear. That's it.
It's the most unbelievable pipe work I've seen in the local. You know, most of the jobs I've been on have been BX and everything like that, and now to be on a purely pipe job is excellent.
They did a good job in spite of all the challenges. The challenges are you could not penetrate into the concrete, so they had to go around. The challenges are there's a lot of test equipment specific things that they could not adjust. In a normal high-rise buildings or hospitals, they have some leeway. And here, the tolerances were really tight.
For Electric TV, I'm Dominic Giratano.
Thanks for that story, Dom. That's it for this video. See you soon back here on ETV. Now, if you haven't signed up a colleague or two for our newsletter, you can do so above by clicking on Newsletter Sign Up.